Let's look at another example of the implicit function theorem. And again, we're going to start off with our capital F function, which depends upon y and x. And it's equal to, again, x squared plus y squared minus 9 equal to 0, which gives us our capital F equation. And of course, this graphs out as our circle. So let's just draw that graph one more time with a radius of 3. And now we want to ask ourselves the question, is the implicit function where y is expressed explicitly as a function of x defined around a given point, say x is equal to 3, y is equal to 0, which is right here, point A. Is it defined around the point x equals 3, y equals 0? And again, to see if this is true or not, if this implicit function is defined around that given point, we have to go through all the conditions of the implicit function theorem, and let's do that one more time. Condition 1. Does this point satisfy our capital F equation? Does it lie on the circle? And again, let's just put in these values of x and y into our capital F equation, and we get 3 squared plus y squared minus 9. And is that equal to 0? Yes, it is. So our first condition of the implicit function theorem is satisfied. Our second condition, all the partials of the capital F function with respect to y and x have to be defined at the said point. So we know fy is again 2y, and evaluated at the said point, that's equal to 2 times 0, which is equal to 0. And it's 0, but it's still a defined value. What about fx? The partial of capital F with respect to x is 2x, and evaluated at our said point, that's just 2 times 3, which is 6, and that's a defined value as well. So we could say the second condition of our implicit function theorem is satisfied. What about the third condition of our implicit function theorem? It says that fy has to be non-zero when evaluated at the said point. But for our case, fy was equal to 0, so that means that third condition is not satisfied. So we cannot conclude that the implicit function is defined around the said point. And let's just see why that is the case. Why can we not conclude that the implicit function is defined around that said point where y is expressed explicitly as a function of x? Again, let's just go back to that circle and look at point A with the coordinates x equals 3, y equals 0. If we were to draw a rectangular neighborhood about that point, you would see for this thick portion of the circle right here, y is not a function of x. For any given value of x, there is more than one value of y, a positive value and a negative value of y. So y is not a function of x. If that's the case, then of course, let's see what happens to its derivative. If we were saying, so we cannot conclude that y is a function of x, and if we were to look at its derivative, dy dx, that gives us some insight as well as to what's going on here. Remember, using the implicit function rule, this was minus fx over fy. And let's see what those values were. Fx was, 6? And fy was 0. So, of course, this derivative is undefined because we're dividing by 0. And that, of course, kind of makes sense. If you look at point A on that circle, what is the slope of the circle at point A? Or in other words, what is the slope of the tangent line to the circle at point A? Well, it's undefined. That slope is undefined. The derivative is undefined. So we have some idea if the derivative dy dx is undefined, then y is not a function of x. Well, the question is when is that derivative dy dx undefined? There's going to be a couple of cases when it's undefined. The derivative will be undefined if fx is undefined, or if fy is undefined at the given point, or if fy is equal to 0. So now if you go back to the conditions of the implicit function theorem, they should make sense. When can we say y is a function of x around a given point? When that derivative is defined dy dx. When will that derivative dy dx be defined at a given point so that we can say y is a function of x? Well, that derivative dy dx is defined at a given point if fx is defined, if y is defined, and if fy is not equal to 0. And now hopefully those conditions of the implicit function theorem will make a little bit more sense.